Hello everyone. Today we are going to talk about aggregate loss models, compound variance. So what's aggregate losses? They are the total losses as paid by an insurance for a defined set of policyholders in a defined period, such as month, year. For example, in year 2018, there are N policyholders and to policyholder 1, insurance pays $4,000. This $4,000 can be more than one claim. It could be two claims. Maybe one claim is $1,000, the other claim is $3,000, adding up to $4,000. So it doesn't have to be one claim. And for policyholder 2, we paid $5,000. For policyholder 3, insurance pays $6,000. So the total S will be the sum of all these Si for each policyholder's I. Aggregate losses S has a compound distribution because it's a combination of both severity and frequency. So many of the time, the compound distribution is difficult to find, so we will try to approximate it. Since if we are adding many independent, identically distributed random variables by the central limit theorem, the sum is approximately normal. All we need to normally approximate a random variable is to know its mean E S and the variance VRS. So once we got the ES and the variance, we can use the normal distribution to approximate that. And there are two ways to model aggregate loss. One is S equal number of claims times claim size. Then the other one is equal number of insured times aggregate claims of each individual members. So the first one is just consider the claims. It doesn't consider any policyholder that doesn't file any claims. It's based on claims. And the other one is based on policyholder number of policyholders insured times the aggregated claims of each individual member. There are many different ways to model aggregate losses. The first one we want to talk about is the collective risk model. Here we just assume S is equal sigma xi, where I is from 1 to n. S is the total losses, n is the number of claims, and xi is the size of each claim. So this is based on claims. First claim maybe $1,000, second claim $2,000, third claim $3,000. This is just example. Now assumption is that xi primes are independent identical distributed random variable. Every claim size has the same probability distribution and is independent of any other claim size. Claim size xi prime are independent of claim count, and we say total loss S has a compound distribution. Frequency N is the primary distribution, and severity X is the secondary distribution. For the collective risk model, the compound variance formula is as follows. Expected value of S aggregate loss would be the expected value of M times X, and it would be the expected value for M times expected value for X. And variance has a different formula as follows. So I'm not going to dive into this deduction of these formulas, but you can look at the process on the right. And there's a special case where n is a Poisson distribution. En will be equal VAN. The expected value n is the same as the variance n equal lambda. Then variance of the aggregate loss S will be equal. First we use the formula then we put in lambda wherever it applies. Then we finally got it's lambda times x squared. That's the conclusion. When it's a special case where n is a Poisson distribution, your variance is equal lambda times ex squared. Now let's look at example. The number of losses on an automobile comprehensive coverage has the following distribution. Number of losses 0, 1, 2, 3, and probability will be 0.4, 0.3, 0.2, and 0.1. Loss sizes follow a Pareto distribution with parameter alpha equal 5 and theta equal 1200, and are independent of loss counts of each other. Calculate the variance of aggregate losses. So to solve this problem, we just need to utilize the formula, which is VARS equal EM VARX plus VARM EX square. Okay, so first of all, we calculate EM and the EN square. EM will be equal 1.3 plus 2 times 0.2 plus 3 times 0.1 will be equal 1. And EN square will be similarly will be equal 2. You just need to use 1 times 0.3 plus 2 squared times 0.2 plus 3 squared times 0.1. So from here we can get VRM will be EX minus EX squared 2 minus 1 equal 1. Now EX, since X is the severity and it follows Pareto distribution, we know the formula for EX is this. Then we got and EX squared is 2 theta squared alpha minus 1 alpha minus 2. Then you can get 240. Then variance of X, VRX, will be equal EX minus EX squared. EX squared minus EX squared equal 240 minus 300 squared equal 50. Now, once we have VRS X and VRM, we can calculate the VRS using this formula. So it will become, the final result is 240000. Now let's look at the second example. The number of claims distribution follows a negative binomial distribution with beta equal 2 and r equal 2. Claim severity distribution follows an exponential with a mean 1000, less 500 per claim deductible in effect. Calculate the standard deviation of the aggregate losses in excess of the deductible. So we are still using the formula from previous page. The only thing is in this case there is a 500 per claim deductible. So basically we let's write out the formula. VAR S equal EM times VAR YP plus VARM times EYP square. This here YP is the payment. Remember, it's only pay when it's more than deductible D. So which, since this is exponential distribution, we know that YP will follow the exponential distribution theta 2 because it has the property of memoryless. Okay. From here we can get EYP equal 1000 and VARYP would be 1002. Now for the frequency, the number of claims follow a negative binomial distribution. So beta n will be 2 probability x greater than d, which is equal to px greater than 500, which will be equal 500. This is just formula here. Then EM will be 2 this VARM will be this. Then eventually you can calculate VARS using the formula to be 7795280.8 omega standard deviation will be square root of that, and it will be 2792. So previously we talked about collective risk model. Now we talking about individual risk model. So in this case, S would be sigma of Si, I is from 1 to n, where Si is each individual total claims. So for each person, for example, you will have a series of claims, but you get them together as Si. Then n is the size of a group, or how many policyholders in this group, which is a fixed number. Then expected value of S, just the expected value for each individual Si, and sum them up together. Then you get ES will be equal n times ES. Then it's n times En times Ex. Variable of S will similarly be deduced as this. Now let's look at this example. For a group of 100 insured, the number of losses per insured follows a negative binomial distribution with R equal 3 and beta equal 0.01. Claim sizes follow a inverse gamma distribution with alpha equals 6 and theta equal 1000. The number of losses is independent of each claim size, and claim sizes are independent of each other. Calculate the mean and variance of aggregate loss. So from what we learned earlier, we know that ES will be equal MESI, so with 100 in this case, ESI, and the variable of S will be equal 100 variable of SI, And for each Si, we can calculate expected value. ESI will be equal En times Ex, and where we are Si, still using the formula En times Vrx plus Vrm times Ex squared. So let's calculate Em first. Em will be equal R beta. So 3 times 0.01. Because this is a negative binomial distribution, so we are M will be equal R beta 1 plus beta will be equal 3 times equal this. Then Ex will be equal, because for gamma distribution, use a formula 1000 times 5 times 200. Ex squared will be equal theta alpha minus 1 alpha minus 2 1000 square 50,000. So Varx equal Ex minus Ex squared. It's okay, I'm gonna skip to 10,000. Then from here you can put it into these two formula, calculate this Es to be 600 and Vrs to be 151200. Earlier we talked about variance for the compound distribution, which always assume that x and m are independent. But what if x and n are not independent? So here we are talking about this. When xi and n are not independent, but n given theta and x given theta are independent, or n and x given theta are independent, then expected value of s given theta is equal expected value of m conditional on theta and times expected value of x times conditional on theta. Then variance can be expressed as follows. And the variance, so variance as the formula for it would be this. Let's look at an example. Claim counts follow a Poisson distribution with mean equal to claim size exponential with mean equal theta, and the independent given theta. Theta varies by insured and is uniform on 0 to 12. Claim counts and claim sizes are independent. Calculate the variance of aggregate losses. So again, the formula is we are S given theta will be equal Em VR x given theta plus Vrm E x given theta square. Since we have Ex given theta to be theta, and Vr x given theta to be theta square, This is the Poisson distribution. This is claim size exponential distribution, sorry. And then from here we can get this to be 2 theta n is equal to 2 theta plus 2 theta square equal 4 theta square. Expected value of s given theta is 2 theta. Therefore, the VAR s will be expected value of VAR s given theta plus VAR e theta. Expected value s theta. VAR expected value s given theta. Now here, first one is expected value of 4 theta square plus VAR 2 theta 4e theta square plus 4 VAR theta 4 times 48 plus 4 times 12 or 240. Here is because theta is follow the uniform distribution. That's why we can get E theta is 12 divided by 2 equals 6. And VAR theta is 12 square divided by 12 equals 12. Now E theta square is equal 12 plus 36 equal 48. This is how we get to here. So first we use the formula and express everything as theta. Then based on the distribution of theta, we can further calculate the variable of s. This is how this problem is solved.